Okay, so let's talk a little bit about the two new labs. I call it 4-1 E and F. And this was going to be an SN1 reaction that we already learned in the past. Then same starting material we're going to use to a E1 reaction. So how does that work? I did write a little introduction. If you look at the folder, you'll see it's a little bit, make it a little bit bigger. So I wrote a little introduction and a blackboard. Take a look at it. I drew the mechanism and etc. etc. And at bottom of the page, also on the blackboard, I have the different some of them useful YouTube signal. I appreciate that you take a look at it. So these are very small, so I'm going to go back to my big page, make this a little bit smaller. Where did it go? Oh, here it is. A little bit more small. Okay, so let's try that. Now, for drawing, we have made these things a little bit simple, actually. The lab reports. I'll talk about that in a second. So the first one is we're using the same alcohol to do the SN1 and E1, so it makes it easier. Reaction condition is a bit different. For SN1, we use 2-methyl 2-butanol. Remember, this is 1, 2, 3, 4. So it makes it a little bit easier to use the same reagent. Now for the SN1 reaction, we use HCl. So in this case, when we make the water, so the water basically is going to be a living group. So we have an acid-base reaction. I didn't put my bond here. So if this is my base, and I make a water and Cl leaves, so this is a carbocation formation. So the water leaves, and I make a carbocation. So this carbocation is tertiary common between for the both reactions. Now here I have a Cl minus as a nucleophile. The Cl minus come back as a nucleophile. And then we're making our product, which is again, replacing the OH with Cl. So we have 2-chloro, 2-methyl butane. Now let's take a quick look at what I ask you to do for this reaction. So again, I'll make this over here, make it a little bit bigger. Sometimes it's not easy to see the type page. I don't know why. So then there are a couple things that as part of this lab report you need to fill out. It's not that complicated, very easy. So there's a table, reaction table. So I'm asking you to look at the reagent that we use for this reaction. So we have 2-methyl 2-butanol HCl, sodium bicarb, and magnesium sulfate. So there are a couple of reagents. And for each of these, I'm asking you to look at the molecular weight, density, boiling point, and melting point, and fill the boxes. So this box is pretty straightforward. So you fill out, and again, the easiest thing is really do it by hand and just scan it or take a picture and use it as a PDF, send it to me. Then we also ask students to look ahead because we are making a product. So the product that we're making, as I said, is 2-methyl 2-chloro butane. So again, I ask you to look at the molecular weight of the product, density, boiling point, and melting point. And typically we can't do it here in this class, but we have a little procedure. So the procedure is really very straightforward. So in this case, we use a separator funnel. We use a little bit distillation. All those things are on the video, so I'd really like you to look at it. So we have a procedure. Then before coming to the lab, we have very simple pre-lab questions. So we have a pre-lab questions that I'd like to fill out here. Then the second page is only, I think it's only 2 pages. On second page, this is what we do in the lab, but now we don't have a lab. So what we have here is the information for the lab. So I put it in. So I said to myself, okay, how much of the alcohol did we use? Because we usually measure it by the volume. So I propose that we use 20 ml of the alcohol and 50 ml of the HCl. Now, I should have blocked this out, but I left it there. It's a good system to remember. We have a density for this. So from the density, we can measure how many grams of that we use and how many moles of each of these two reagents we use. So these 4 boxes are calculations. So these 4 boxes are calculations. Then we have boxes for the product. Again, because we didn't do actual lab, but we propose that during this reaction, so during the product, we collected 10.5. I didn't write down the gram, so it's just, yeah, I did it here. So we collected 10.5 grams of the product. Now remember the yield, what the yield is. So the yield is assuming the number of moles, every moles I have for the alcohol went to the same number of moles for the product. It's not always true, right? It's not always the truth. So if I convert the number of moles of the product to the gram of product, so that goes here. So that's what we ask student to. So how many you should really have? Of course, we never have that much. We have always a little bit less. So now the yield, we can measure the yield. So the yield is with the gram produced over gram for 100% yield. Or we can do the number of moles. Either way is fine. So we need to report based on that 10.5 grams, what percentage yield we have. Then here, number 3, we're asked what would be we asked what to draw the mechanism, but if you go to introduction, you have that, right? So we need to fill out this part. And then during the workout, we have a little bit pressure buildup, and you're going to read the procedure. And so what that pressure came from, question number 4. And then question number 5, ask yourself, is distillation a good way to do this, or is not, or is there any better way to number 5? So it's very simple. So you do a little bit, I'll put this paper back, make this a little bit smaller. So you do the pre-lab, basically fill out the tables, look at the procedure, because you need that to answer a few questions. Then 2 questions here. Page 2, we have the numbers, right? How many ml of alcohol we use, how many ml of acid we use. And based on that, we fill out some form here. Then I propose that we collect 10.5 grams of the product and we report the yield. And then a couple questions here to answer. So this is for the SN1. It's very easy, 2-page, fill it out. Of course, look at the introduction and take a look at the video that I have there for you to look. Thank you.